Okay, we should begin now. Let me start recording. Is my sharing visible?
Yes, sir.
But the recording
Yes, sir.
hasn't started yet. So, anyways, while the recording starts, let's just recap for what we have about what we have learned in the last class. So, in the last class, we got familiar with iteration statements. Iteration statements basically does nothing but repeats a loop body or another statement finite number of times generally based on some other conditions. So we have taken a look at two of the three iteration statements that are available in the. We have taken a look at the while statement, which looks like this. As long as the expression is true, the loop continues to execute and the statement is executed continuously one after another. This is one example. Then we have taken a look at the do statement. It is quite like the while statement, except it makes sure that the loop body is executed at least once, and afterwards the expression is checked. And then we took a small look at the basic structure of for statement, and today we'll try to take an in-depth look at how for statement works. So if we take a look at the basic structure of the for statement, it has actually three expressions inside the brackets. The brackets are mandatory again. Expression 1 separated by a semicolon. Remember this one. Expression 2 separated by another semicolon. And then expression 3. And afterwards, we have a statement or the loop body. Again, this can be a compound statement. So this is an example of a for loop that we have seen actually. This is the initialization expression. That means it initializes a single variable. This is the conditional expressions, that the condition that is checked before the execution of each loop body. And this one, third one, it is generally called the incrementation or decrementation statement. That is a statement that is executed once every time when the loop body is finished. So we'll take a look at each of these expressions one by one afterwards. So this is one example of for loop. It first initializes I equal to 10. Then it goes inside the actual loop. At every step, it checks whether I is greater than 0 or not. If it is true, then it brings this loop body based on the value of I. Then it decrements I by 1, I minus minus. Then it goes again to check the condition, print it, and decrementation. And as long as this condition is true, it keeps on looping. So as we have already seen in the last class, that except for few rare cases, there are rare cases, generally a for loop can be replaced by an equivalent while loop. How? Because the expression 1 is the initialization expression and it is executed only once before the first execution of the loop body. We can put it outside expression 1. Then we go inside the loop body, or inside the loop itself. We check the second expression, which is the conditional expression, which controls the loop. Then we execute the loop body, and afterwards we check for expression 3. Afterwards we execute expression 3 every time, and then go back inside the loop body. So if we have to take a look at for loop, we can write it like this: for I equal to 0, I is less than I plus plus. Let's bring out the value of I for now. Okay. And this would print from 0 up to 9 because it is less than 9. So this thing, if you want to convert it to an equivalent while loop, I is equal to 0, while I is less than n. Then we do the loop body, which is okay. And then the incrementation, which was I plus plus. So I can write this. This needn't be I plus plus, it can be I plus equal to 1 plus equal to 2, I is equal to I into 5, whatever you want. But generally, or actually, these statements should always have some kind of side effects, because they are generally the control variables of the loop, and so they should have side effects. Now let us take a look at the different expressions of the for loop in details. So the first one is the initialization step, performed only once before the loop begins. The second expression is the controlling expression, checked every time before the loop body executes. And the expression 3 is performed every time at the end of each iteration, they're generally incrementation or decrementation. And again, the countdown example that we have seen before, like in the while. Okay, I'll not go there. So basically, this is the equivalent while for countdown for this for based countdown. 10 to 1, it means t minus 10, 9, 8, 7, 6 to 1 and counting. And this is the same thing using while 10 to 1. And since I plus plus or I minus minus is in different line, whether it is I minus minus or minus minus I, doesn't matter. Now, if I take a look at one thing, these two statements, I is equal to 10 and I minus minus, they are executed on a different time. The value of those expressions are not stored anywhere, or they are not used in any place. So they need to have an operator with side effect in them. When you have operator with side effect in them, what happens? Some value gets modified in place. Like if I is equal to 10, I gets modified in place. 10 is stored inside I, or I minus minus, that means in place I gets decremented by 1. So since operators with side effect modifies the value in place, these kind of statements work. So if you do not put an would not put a statement with side effect in there, they will basically become useless statement. That means something is happening, but you are not utilizing it at any place. So anyways, these are some of the common norms that we actually, or some of the common idioms that we use with for loops, and you will encounter them quite often. So one thing, though in real life we are familiar with like counting from 1, 2, 3, 4, 5, 6. Like if somebody asks us to count 5 items, we would count them 1, 2, 3, 4, 5. However, in programming, in most programming languages and in programming, the counting begins from 0. And if someone asks us to count 5 items, we'll number them as 0, 1, 2, 3, 4. Though it may seem a bit counterintuitive to you for now, but whenever you grow up and you get more accustomed to programming and you solve different kind of problems, you'll see that this kind of method is actually really beneficial. So like 0 to 4, you can do a lot of mathematical calculations with those things using these values, and they will actually help you to get those calculations done properly. But there are actually other languages where the counting by default begins from 1. If you're using a language like MATLAB, the counting begins from 1. But in C or in most other languages, modern languages, the counting begins from 0. And what is this beginning of counting? We'll see it when we like discuss about arrays. So anyways, this for loop I is equal to 0, I is less than n, I plus plus, I is less than n. So it counts from 0 to n minus 1. This one, 1 less than equal to n. It counts from 1 to exact value of n times. This one also counts n time, but the beginning and ending are different. I is equal to n minus 1. I is greater than equal to 0. I minus minus. This is like downward counting by decrementation. So it will start counting from n minus 1 and go down to 0 again n times. And this is another thing. It goes from n down to 1 again n times of counting. So some common mistakes that people generally make in like for loops are mistakenly writing less than or greater than, or mistakenly exchanging less than with greater than, or similar mistakes in controlling expressions. This can also happen in like if, and using equal to instead of like less than equal to, greater than equal to. Generally using equal to is a mistake, because whenever you're writing a for loop, basically you are targeting for a range of values, right? So there will be more than one. And when we define range, each type of range generally has a starting point and generally has an end point. So since we have a starting point and end point, we generally check whether we go out of that ending bound or whether we go out of that starting bound or not. If you are checking equal to, that doesn't make any sense in those cases. We start at a point and we go until the range is finished. That's the whole meaning of the for loop. So if I just like I equal to n, so this condition for loop continues as long as this condition is true. And when you write like something equal to some other thing, if that is associated with the controlling variable like I for this loop, in those cases there is only one time when this statement can be true, like only when I is equal to 10. So if that had been the case, a loop isn't the perfect thing to do those kind of thing. We can use like selection statements like if or maybe switch if you want to change something. So anyway, selection statement is your way to go when you want to match something equal to. There are cases where we actually use like equal to inside for loops. We can do that, but other than that, generally you would expect less than or greater than or less than equal to or greater than equal to operators here. And this is a very common error. It's called off by one error. All of those who have written program, they sooner or later actually face this error, and they keep on facing this error. The main concept of this error is you're like supposed to count from 0 to n minus 1, but you have counted from 0 to n. Or maybe you are supposed to count from 0 to n, but you have counted from 0 to n minus 1. When you are like dealing with complex problems or when you need a lot of mathematical calculations, you might, in your head, you know that you need to count up to that point, but you cannot like determine whether that point is n or n minus 1. As a result, you count either one less or either one more. It is a very common one since generally, we miss by one or so. So that's why it's called off by one error. Like I'm supposed to print from 0 to like 9. However, I have distinctly written less than equal to, and now I'm counting from 0 to 10. Or I've written for like 0 plus n, n plus 1, or maybe less than equal to n minus 1. This one is actually correct. We wanted to count from 0 to 9. So this one will work. And less than 9 will work. But if I write less than equal to n, in that case, I have actually made off by one mistake. So we need to avoid those kind of scenario. So any question up until now?
No, sir.
Okay. In that case, let's move on. The next topic is called omission of expressions. There are like 3 expressions, right? This is one. This is another one. One or more of them can actually be omitted. The first expression, the second expression, or third expression. So the first expression is actually the initialization statement, right? So if we ever omit them, we need to initialize the controlling variable of the for loop by ourselves. Like we have omitted I is equal to 0 now. So what will be the starting point of the loop, or what will be the starting value of I? We can just write I is equal to 0 here. That will work fine. Again, it is the exact same loop now. Or what we can do, we can also write like I is equal to 0 here as well. It's also fine, and this will work. So omission of initialization, omission of the first expression means you need to do a manual initialization. Anyways. So before going to the second expression, let's go to the third expression. It's the increment or decrement expression, right? So we can also omit this. It is fine. Basically, in that incrementation or decrementation slot, nothing will be executed. So we do not have the incrementation value anymore. But if you run this, since the value of I is not getting incremented, I is always 0. So the second expression will always be true, and it will enter an infinite loop, which is continue to print value 0. So what we can do the implementation manually by ourselves. We can write at the end of the loop that we want to implement a plus plus, just like in the equivalent while, and it will work. We can actually omit both the first and the last expression. So in that case, we both need manual initialization. We need both manual initialization and manual implementation. And if you take a look at this, these two are exactly same. So when you omit the first and the last or the third expression inside a for loop, it becomes a while loop in disguise. Okay. While loop in disguise. If you omit the first and last expression. So now let's come to the final point. I'll restore the loop to normal. What happens if you omit the second expression? So this is the conditional expression. When you omit this one, a blank statement here actually means always true. It's equivalent to 1. In case of for loop, if you leave the middle expression or the second expression blank, it means always true value. Like if I write like this, this is now an infinite loop. If the middle statement is missing, we can definitely initialize something here and increment or decrement something or do some other operations here. But this means an infinite loop. It's always true. So if you want to like break out of this kind of loop, we need to trigger manual breaks. Yes? Any question? Yes, you can put a float variable. You can use any type of data you like. You can use like float here. You can use double. When you're familiar with it, you can use characters. Any valid data type you can do here. These are like statement slots. You can do anything here you actually like. Just remember when they are executed. This statement, the first one, is let's do it to normal. So these are just statement slots. Remember the execution order. This one is executed only once at the beginning. This is a condition that is checked every time. And so based on whether it is true or false, things are executed. And this is the expression that is executed every time at the end of the loop body. So you can, this can be anything. It can also be a float or anything you want. It can be float. That's fine. I is equal to 0.7. So completely fine. Any other data type, also fine. You can also put printf statement here if you want. We'll take a look at that later.
Sir, can we use complex statements? For example, and or or?
Yeah, definitely. If you want to check multiple conditions, that's not complex statement, right? That's just complex expression. So
Okay,
the statement is simple. And like maybe I not equal to 50, or maybe I not equal to 55. I don't know why 55, but yeah, I want to do it. Completely fine. You want to chain a larger condition there inside the loop, completely fine, no problem. So this is an example. Shows you. And if you omit both all basically the middle expression, it becomes an infinite loop. So let's now take a look at something that C99 has introduced. We barely use C89, by the way. We barely use C89. In most cases, we actually use C99 or above, and in most cases, we're actually compiling with either C3 or C11, but the latest standard will be C17. So in some cases, you might actually be using C17. You can actually define your own standard of compilation. If you're using like GCC from the command line, you can write like, if I want to compile it with, you can see the command line here, right? Also here. So if I want to like compile it in a specific mode, I can write this -std is equal to, then if I want C89, I need to write C89. If I want C99, I can write C99. I can write C03. I can move towards C03, C17, C11. Those are the different standards. Do not put any space between this type of commands. Okay? Do not put any space between this thing. It should be in a single line. If you want to specify standard, but you do not need to. Sorry, you do not need to worry about this for now. So what C99 allows us actually to declare variable or the initialized variable right inside this for loop. That means I do not, I'll make it integer again. I do not need to declare this int I here. I can declare it just like integer I is equal to 0. I is less than n, I plus plus. Remember, this is a feature of C99, which is not available in C89 or prior versions like KNRC. So in case of this, the variable I is automatically declared inside this for loop. And we can use the variable and only once. It is declared only once, and for the rest of the looping time, it is persistent. So integer I is equal to 0. So what's the benefit of this? We know that this variable I is actually only associated with this for loop, right? It has nothing to do with something else outside in most cases. It is there so that we can control our for loop, or this is the controlling variable. That's why this variable should only be associated with this loop. That is our logic, and that's why we have declared it as the first expression, integer I is equal to 0. Then normally the conditions and the incrementation or decrementation. As a result, we can actually access this variable I inside this loop. It is fine. Just a moment. However, if you want to access them outside, it is not available because identifier I is undefined. This I is only visible inside the loop. But this is not allowed. Like we cannot set the value of I or maybe print it outside because our I is not declared outside. Yes, the question.
So suppose we have a for loop inside another for loop, so a nested for loop.
Sure.
In that case, can we actually use the same variable in both cases?
No. So what will happen if we use the same variable? I'll tell you. Like we can also have another variable like integer I here. Okay, first take a look at this. Whenever you redeclare the integer I inside, generally a redeclaration of a variable is not allowed. Like if I write another integer I again, it should throw me an error. It's not throwing, but it will throw me an error that I'm redeclaring a variable. Redeclaring a variable is not allowed. Why? Because it has some problem with that defense anyways. But whenever you declare them inside the loop and you have another variable with the same name outside, it will not cause any conflict because this I and this I are not same. They are different I. And we know this I is only available inside, not outside. Whenever you go inside this loop and you write I, this I has higher priority than the I that was declared outside. And this is why this I inside the loop will always print the value of the variable attached with this loop. And this phenomena is called, or this thing is called, like overshadowing of variables or shadowing of variables. That means this I is shadowing the I outside. So as a result, what you asked, like if I write another loop, like for integer I is equal to 0, I is less than, let's say 5, and use a fixed value I plus plus, then do something. What will happen? Now this will get actually confused. This loop will actually execute 5 times. It should. However, you cannot access the value of this variable I inside this loop. Whenever you are using a doubly nested loop or even a higher level of loop, you generally want both the value outside in the outside loop and the value inside the loop to be available to you. And if you write code like this and like printf percentage, let's call it inner loop. Inner loop I is equal to I. Inner loop will loop 5 times. I will make it loop like the outer loop 3 times. To be sure. Call it outer loop I percentage. So you see that it would print like I0, then go inside the loop, it will print 0 to 4, and then again go outside again, it will print 1. However, we have no access to this variable here. So if I just run this, I'll omit this one. Now both the I's are like disjoint in this up. This is the outer loop I, 0. The inner loop I is 0 to 4. The outer loop is 1. Again, it becomes 1, 0 to 4, 2, 0 to 4. So it's kind of like conflicting. And for the reader, it also becomes difficult. So, and it is generally not used. So whenever you are like writing double nested loops, generally you want both the values to be accessible. Because if you try to visualize a double nested loop, if you want to visualize a double nested loop, it is kind of like this, like these are the entries. This one. Think of this like A1, A2, A3, A4. So this is like a double nested loop. Like there are rows and there are columns. This is a way to visualize those. So whenever I'm writing I is equal to 0, I is less than 3, I'm actually choosing the column. Sorry, I'm choosing the row 1, 2, 3, 4. And whenever I'm writing like a inner loop or this second for loop 0 to 5, I'm actually choosing which column I'm in. First column, second column, third column, fourth column. So if I write the values like 0, 1, 2, 3, 4, 0, and these are the values of like these are the values of like the inner loop, and these are the values of like outer loop, the control variables. That's why in those cases we generally declare them as I is equal to 0, and in that case we can actually print something like this. Let's just print them in the brackets, and let's put space afterwards, I comma j, the new line after. If you run this one, so if you try to read the coordinates of this like table, this one is 0, 0, afterwards 0, 1, 0, 2, 0, 3, 0, 4, again 1, 0, 1, 1, 1, 2, 1, 4. In this line 3, 0, this one is 3, 4. If you just compile this one, check what happened. I've written it as I. It should be J. So we control the outer loop using I, the inner loop using J. And if I compile and run this, now you'll see the coordinates of that table printed, like 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Then this loop ends. This line executes. We go to a new line, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. Okay, I've written 3 and actually given 4 columns here. So if I want to match that one, that's properly. So that is why you do not want to use the same variable unless you know that, okay, I do not need to use this variable, the value of this variable anywhere inside the loop. And in that case, if you want to use that, it is fine, but it becomes hard for the reader. Declaring a single integer variable is like nothing for a computer program. So yeah, just declare a new variable to control them.
Thank you so much, sir.
Okay. So we said that we can declare the variables by ourselves here. And if you want to declare more than one variable, that is also fine. We can just use comma here. This is another operator called the comma operator. We can just use comma and we can declare another variable, maybe j is equal to 5. And then we can do like j is equal to 5. So I will be initialized with the value 0 and j will be initialized with the value 5. Okay. So, but there is only one condition. We can use multiple declarations, but all of them, like I, j, whatever, needs to be of the same type. Like if I started with I as a float, then I will be float, j will also be a float. Okay. So we only a single type of is allowed for multiple declaration. You can use all integers and declare as many integers as you want inside here, or you can use like float or double or character and use many float, double, or characters respectively inside there as you want, but all of them needs to be of a single type. Similarly, in the last statement, we can also like in the last expression, we can also like chain multiple things together using the comma operator. Okay, this thing you can also do it in like C89. Like if I was declared outside ij, integer ij, in that case, this is completely valid in C89 as well. What C99 adds for you is the way to declare the variables themselves right away inside the loop. Integer I is equal to 0, j is equal to 5. This is completely fine. So what will happen if I write printf values of I and j here? Percentage E. If I run this one, I goes from 0 to 3, j counts down from 5 to 2. So yeah, so you can use declaration in case of C99, and in C89 and 99, in both, you can use the comma operator. However, if you're using a declaration, that means you're declaring all of them now. You're declaring all of them now, and all of them needs to be of the same type. Yeah. C99 allows the first expression and first statement to be declaration. Yeah, there you go. And more than one variable declaration is allowed using comma operator, but they must be of same type. And now let's take a look at the comma operator generally. So we use them outside, like whenever we declare two variables together, like yeah, this is where one case where we actually have been using comma operator, but we didn't talk about it. So, but the main place where we generally use comma operator for its own purpose is inside the for loop or some other loops when we need them. Generally used inside loops for more than one initialization expression or several increments, like I have shown, generally used in first and third expressions. You can use them in second expressions, but that doesn't make any sense. But yeah, you can do it. So comma operator is actually a binary operator. That means it works on two operands, and it generally looks like this: expression 1, comma, expression 2. So how do we actually evaluate the value of a comma operation and what are their precedences? So comma operator actually has the lowest precedence of all the operators that is available in C. Of all, every operator, among all the operators, comma has the lowest precedence, remember them, and they are left associative. So we'll take an example of association afterwards, but how do you evaluate them? So we evaluate them in two steps. First, expression 1 is evaluated, and then the value is completely discarded. And then second expression is evaluated, and it takes or it becomes the value of the entire equation or expression. And this is why the expression 1 must have a size defect. What does this mean? Okay, let us just see by an example. Let's say integer I is equal to 10, j is equal to 200. What I can do, and there's like another integer, let's say for now, okay. I can write I plus plus, comma, j minus equal to 100. So this is an expression which is joined using, or where the operands are joined using a comma operator. What comma operator says is that the first expression will be evaluated here. So I plus plus means after the evaluation of I plus plus, I will become 11, and this expression will have by itself the value of 10 because it is post increment. Now it becomes 10. Then j minus equal to 100. So what does this mean? J minus equal to 100, j is equal to j minus 100. Afterward, j will become 100, and this expression will be evaluated to 100. Now there's only elementary and a comma operator. What comma operator says? The evaluation of 10, 100, the first value will be completely discarded, and 100 will take its place. I mean, that is the evaluation of the whole expression. So since we are not using it, it is not affecting us in any way, but we could have used it like this. K is equal to, I'll put a bracket to make it clear. And if I do not put k, this value will be evaluated first because comma has the lowest precedence. That's why I put the bracket. We can write like k is equal to, in bracket, I plus plus, comma, j minus equal to 100. After the evaluation of this one, I will become 11. This will be 10, like I have shown. And j minus equal to 100, j will become 100. This whole expression will be treated as 100. 10, 100, this whole comma operated thing will be evaluated to just 100, and k will also become 100. This is how it should work. You can print out the value and try. Rest of it. Becomes 11, j become 100, and k becomes 100. So even if I wrote like something like k is equal to like 2000 or like whatever 200,000 and then 2. Can anybody tell me what will be the value of k after I evaluate this expression?
2.
Yes, k will be 2. So let's take a look at association, like 100 minus 1 and then maybe 5. So this is like comma operator thing, some value separated by comma. And since comma operator is left associative, what will happen? These two will be grouped first, and then the next one will be grouped, and then the next one will be grouped, and then the final one. And what will happen? They will be evaluated step by step. 200,002 will evaluate to 2. 2 and 100 will evaluate to 100. 100 and minus 1 will be evaluated to minus 1. And minus 1 and 5 will be evaluated to 5. If you see a series of values chained together using comma, just take the last value, and that will be the evaluation of the whole statement. And this is why, since the first initial expressions are all being discarded, they have no normal effect. So we should have in them operators with side effect. So that will be helpful for us, or that will at least mean something. And this is another example of like chaining together comma operator, and this is how they will be grouped. Remember, comma has the lowest precedence. So if I have just written like k is equal to 5 comma 10, it basically means k is equal to 5. It will group like k is equal to 5, and then this whole expression will be evaluated to 10. But since we are not assigning them anywhere, it will become useless. So remember the order of evaluation. So print a table of squares using for statement. I have already shown it to you in the last class. I do not think I need to show it to you again. Do I? Anybody? Do I need to show it to you again, or can I skip?
No, sir.
No, sir. No need.
Okay.
You show us.
Okay. So one of you want to see?
Yes.
Okay. So our task is to take an input from the user, let's say the value of n. And if the value of n is like, let's say 3, what I want to show to the user, 1, and the square of 1 is 1. Then I have 2, the next value, and the square of 2 is like 4, and then 3, the square of 3 is 9, and I will break out. So I want to print the squares in this beautifully formatted way. So I can like prompt the user to enter a value of n, and then I can scan it from the user. And then what I can do, I can actually run a for loop. I need to run from 1 to n, right? So I can initialize integer I equal to 1, I is less than equal to n, and then I can write like I plus plus. And then I just need to print out the values in a formatted way. And since I need to format them, and I do not know what will be the length of I, since the value of n is dynamic, n can be 100, 1000 as well. So I'll just, to be sure, I'll just use maybe like something %6d, %6d, and let's go to a new line, and comma I into I, since we're printing the square. Now if I run this code, first it asks me for a value, let's enter 5, and means 1 square, 2 square, 3 square, and so on. And if I put a higher value, let's say 10, it still works. And if I put another higher value, like 100, again it works. Okay. So the square table will be printed. So this is the square example. But what's actually funny is the square example using odd method. So let's take a look at the odd method, which I have corrected, but I shouldn't have. So let's just do some shenanigans. So believe or not, this code also prints the square of the values inputted by the user. So let's just try or compile this one and run this one. Enter 5, and it prints the square of the square table as well. However, this one operates a bit differently. This one doesn't use multiplication, rather it is built using a chain method. It starts from the beginning and then adds some value to it continuously, and then final value is printed. How does it work? So it starts with the square value, the I value as 1, odd value as 3, and the square value as 1. At each time, it adds the odd value with the square value. After the square value is printed, then the value of odd is also incremented, and it goes to the next one, and then again it prints the square value. So if you want to visualize this one, let's say initially we want the control variable. This is the column for I. This is the row for I, and this is the row for square. So initially the value of I is 1, and the value of a square is, and let's take another for odd. So initially odd is 3, okay, and square is 1. So 1 square is 1. Afterwards, I becomes 2. Odd, 2 is added with the odd, and this odd and square is added together like 3 and 1. These 3 and 1 are added together, and afterwards the square becomes 4. See, 2 and 4, it matches. 2 is added with the odd now becomes 5. Each time odd is incremented by 2. And in the next step, I becomes 3, these 5 and these 4 are added together for square. Square becomes 9. Square plus is equal to odd. This one matches, odd becomes 7, incremented by 2. In the next step, I becomes 4, odd, 2 more is added with the odd, but we'll go that later. And these 7 and these 9 are added together for the value of a square, and it becomes 16. So if we take a look at this value of I and the value of square, they are complying. So that's not our main focus here. Our main focus here is that if you take a look at the loop, the initializer variable square is equal to 1. The next step I is equal to n, and the third step odd plus equal to 2. All the variables here are actually different and are not related to each other. So nothing actually forces you to use a variable or use the same variable in all the 3 expressions of the for loop. However, when you write something like this, a for loop like this, it is actually it becomes difficult to understand. And it isn't coherent because the variables that you are using inside the expressions of the for loop should be something which is used to control the for loop. So if I just reformat this code, like instead of writing square is equal to 1, I will cut it, paste it here, and I'll declare I is equal to 1 here. For now, let's omit this one, move the value outside. I is and n is fine. And instead of writing odd plus equal to 2, what I can do, I can omit this. I can plus equal to 2 here. And I'll just put I plus plus here. Now if you take a look at this code, it is the exact same code, except we have reformatted it. And now it is far more easier to understand. That means we start with the initial value of odd, we start with the initial value of square, and then we initialize the I equal to 1 here. We could have initialized odd and square here inside the for loop as well, but we didn't do it because they are not related to the for loop. So it makes it cleaner and easier to read. Then we go up to n, and at each step we increment I. This is the normal one, but then we just print I, the initial value, and the value of a square. And then we just increment the square value by the previous value, adding the previous value of odd with the square, according to this table, like this one.
Sir,
Yes.
sir, could we write the odd expression and the I expression both in the expression 3 slot in
Yeah,
the for loop?
definitely. Yeah, we can add to odd plus equal to 2, yes. But why didn't we do that? It is allowed, but yeah, it becomes difficult to read because odd is not something that is related to the control of the loop here. So by convention, generally, whatever is put at those places are the variables that are actually needed or that are related to the control of the for loop. That's why we didn't put it there.
Yes, sir. Thank you.
Like if you want, like, okay, if you want, let's just do something. hope it works. There you go. That's it. That's the whole loop. Put inside the for. Okay. And this body looks ugly. Okay. I can omit this one and put a semicolon here. This is null statement. I'll show it to you afterwards. So yeah, if we want, we can write the whole thing inside the for loop. It was looking ugly previously in the very first state, and it is now looking even more ugly. This one works. But is it readable?
No, sir.
Yeah, that's why we do not. Yeah, that's why we do not do those kind of things. Keep it simple.
Okay, sir.
A lot of things are possible, but we do not do everything every time. Basically, use or keep variables here that are related to the control of the loop. Okay, so we'll take a look at the null statement. We'll be back there, but let's now talk about exiting from a loop. Now, if you take a look at like while or do while loop, like for while loop, a while loop is something like this: a while, then we have a condition, and then we have the loop body. So first the condition is checked. If it is true, the loop body is executed, and then again the condition is checked. If the condition is false, then it breaks out of the loop, right? So the breaking point of for loop is at the while loop is at the beginning, right? Similarly, for loop, the condition is checked in the very beginning of the loop, and if it is proved to be false, then the breakpoint is here. It gets here. And if you're using like do while loop, case of while loop, so body is executed first, and then the condition is checked, and if it is proved to be false, then it breaks out here, right? So for loop and for while loop, the breakpoint are at the very beginning, and for do while loop, the breakpoint is at the very end. So what happens if we want to break out at some position else? Like maybe there are like five statements inside this compound statement, and somewhere in the middle, based on some condition, we want to get out of that place. I've already shown you, like while taking infinite input from the user, we can use the keyword break. Whenever the keyword break is triggered, it breaks out from the loop right at that place. Like if something condition, then we just break out of that place. So we can trigger conditional breaks. We can have multiple breakpoints. Before breaking out, we can maybe set some outside variables value to something to judge, and we can break out. I will take a look at an example. So if you want to break out at arbitrary places based on some of the conditions put by the user or by the programmer, we can use the break statement. It jumps out of a loop. For instance, let us check at an element or at a like naive approach to finding prime numbers. A number which cannot be divided by any value other than 1, and the number itself is called a prime number. So we want to check whether the value n, whether the number n, which we will like take input from the user, %p, and n, we want to check whether n is prime or not. So how can we check? A very simple approach to start from 2, because every number can be divided by 1, and dividing by 0 actually doesn't make any sense. So we can start from n equal to 2, sorry, a divisor equal to 2, and we can go up to n or before n. If any number before n can actually divide n, if any number before n can actually divide n, we can say that n is not a prime. And if the division does not occur, it means n is a prime. How? We can write for it's an integer, let's declare d outside because we will need it. Or we'll start with 2 because checking with 0 or 1 doesn't matter. D is divisor. For d is equal to 2, then we can say d is less than n because we need to check up to n, and d plus plus because n will divide itself. If n % d equal to 0, that means n is divisible by d. then what we will do? We'll trigger the break. Okay. So if the break never triggers, that means n is a prime. What will happen? D will go from 2, 3, 4 up to n. Like when it was like n minus 1, this condition will be true. Afterwards, D will be incremented by 1 more. Then D will actually become n and then break out of the loop. D is less than equal to less than n. When D will become n is not less than n, and it will break out of that loop. So afterwards, we can actually check that. Like if D is less than n, that means if the condition break was triggered, because if the break was triggered, that means D was less than n. Because only in those case, n was divisible by D, D was less than n, and so it broke out of the loop. We can say that, okay, if it is less than n, printf percent n is not prime, it is divisible by something. So n is not prime, n is divisible by D. Otherwise, we can just print that printf n is prime. Just compile on this one. I've overwritten it, but that doesn't matter. So, like if you write 10,
the percentage in the last percentage in the industry.
okay. So 10 is not prime, 10 is divisible by 2. If you run it like enter a prime number, 13 is prime. So that's how this thing is working. Is by triggering a premature break, we're getting out of the loop early. And then by checking it, we can say whether it is a prime or not. So this is an example of break statement. Break can be used with like for, while, do while loop, and you have seen that we have break inside switch statement. But remember one thing, if we have like a double nested loop, like for something, and then inside that we have another for, and in that we have actually triggered a break somewhere, it will only break out of the inner loop and the outer loop will continue. If it has another next iteration, it will go inside the next iteration and it will go inside this for loop again. Break. So yeah, a break can only take you out of the inside innermost loop where the break was triggered. Like for example, this is the example. Here, if we have a while statement and inside a switch statement, if we have a break, the break will break you out of the switch statement, because break actually breaks you out of the switch statement, like I have shown before. Break will break you out of the switch statement, but not the while statement. Remember that. So is there a trick that we can use to break out of this one? Yes, there are many ways we can do. So a simple thing what we can do, like for integer, I is equal to 0, and let's declare another integer, but we're treating it as a Boolean value. Let's say flag 1 is equal to true 1. It is true. I is less than 10. Let's say we want to look 10 times. Let's attach one more condition, and that is, and as long as the flag 1 is true, and then I plus plus for integer j is equal to 0, comma, let's for now we do not need it, but declare another flag for this loop, flag 2, j is less than 5, and then flag 2, j plus plus. If let's say j equal to 2, we want to break out of both the loops. What we can do, we can trigger flag 1 is equal to false, 0, and then we can pause the break. So what will happen if we write like flag 1 equal to 0? Well, first of all, when j is equal to 2, it will trigger flag 1, it will make flag 1 0, this flag 1 as 0, and then it will break. This break will only take this loop out of this inner for statement. It will break out of this loop and come here. When it is here, the statement is finished and it will go inside the beginning of this for loop again, and it will check for this condition. Now we have actually set flag 1 as false, right? So since flag 1 is false, this condition will prove to be false and it will break out of this loop as well. So this is one method, and if you want to use, like, if you're not sure, there are some other statements that should be skipped after this for loop. Maybe like we have done some more implementation of I here for some reason, I++, but we want to skip that. What we can do, like, we can check if not flag 1, and then we can break out as well. So when you trigger break in the outer loop, it will break out from the outer loop. So there are a couple of ways you need to play with it to figure out how to do it. There is a way to completely jump out of loop, like using a statement called goto. Like go to outside, and this one is outside. It's not being highlighted, but it's fine. So these are called go-to statements. You can use a label where you want to jump. When you write go to something, it will unconditionally jump to that statement. That means whenever this statement is occurred, it doesn't matter, the code execution will jump to that point. However, there is a problem with this one. This violates the normal principle of like a structured programming. You are making arbitrary jumps. So you do not know what will be the proper execution path of the code. So it becomes really convoluted. It's like a reminiscence from the even lower level languages like assembly programs. So I will highly discourage the use of goto, and it will be very good for you if you do not use goto. Unless it is really required, no programmer generally uses goto. Anyways, that's one more way. So we have seen break. Now we'll take a look at another statement. Yes.
So by using goto, can we go up instead of down? For
Sure.
example,
yes, you can go to like if outside was, that's the problem. Like, yeah, we can go to the very beginning of the program as well.
okay.
Okay, we will really jump to the beginning of the program and it will work. But now it becomes really difficult, right? When a reader is reading, it's also very difficult for the reader to follow the execution of the program. Okay, so it's going like up here as again, and then it's going. So what is happening? So it makes the program really difficult to determine. It becomes really difficult to determine what the program will go. Yes. Anyone has any question? It seems like someone raised hand. Anybody has any question? Okay. If not, then we can move on. So the next statement, break was available inside switch as well, but continue. The next statement, which is continue, is only limited to loops. Okay, only available inside loops like while, for, and do while. What happens whenever we write a continuous statement, rest of the loop body of that loop is skipped and the execution goes to the very end of the loop. For an example, for integer I is equal to 0, I is less than n, I plus plus. What we can do, let's say we want to print the odd numbers only. We want to print the odd numbers only between 0 to n. What we can do, if we see an even number, that means if I %2 equal to 0, or not I %2 or whatever, I %2 equal to 0, that means if I is an even number, in that case, continue. That means skip rest of the loop body. The execution will come here. Remember, this is executed after the loop, but it is not considered part of the loop body inside for statement. So I will be implemented. And this is another place where for loop is actually handy. And then it will come here again. If I is not even, this continue is not triggered and the value is printed. Now, if you run this code. Yes, anybody wants to ask a question?
Can we start?
Yes, Fayaz?
Sir, couldn't we just write I is not I modulus of 2 is not equal to 0? I mean, wouldn't that make it a lot easier?
Okay. I'm just showing an example of continue. I'll show you one more thing. Don't worry. So
Yes, sir.
if compile, right. So if you want to write like all the after 15, there you go. 15 was included, 1 to 13. We entered 15 and prints 1 to 13 because it's inclusive. Sorry, it's exclusive of n. Okay. So there's another way, just like I was saying why we write it like this, because sometimes we write like this. An alternate to it is we can only print if I%2 not equal to 0. That means if it is odd, then we can just print the value. This is what you were saying, Fayez, right?
Yes, sir.
Like if it is odd, then we can print the value. Yes. In most cases, when we write continue, that whole thing can actually be done using a simple if-else statement, because we generally trigger continue based on a condition. So if we want to skip the other part, we can put that inside an else statement and it will work just fine. However, just to keep the code simple sometimes, or like keep it clean, people skip it using continue instead of using else. Like, yeah, this is exactly same thing, equivalent of this code. This one is with continue, this one is without continue. So continue is a handy tool if you want to use it, or handy keyword. If you want to use it, you can use it. But in like very few cases, you will actually see people using continue. However, this is not regarded bad. People actually use continue because it lets you know, because it is readable. If something happens, then continue. Do not execute rest of the body of this code. So that's fine. Sometimes people use this thing.
Thank you, sir.
So you can use whatever method you like as long as your logic is correct. So this is a task. Like I will not show you how to do this one, but I would ask you to take a screenshot of this page. Take one and let me know when the screenshot is done. So any of you has taken a screenshot?
Yes, sir, I have.
Okay, and then take a screenshot of this one. Okay, I hope it is done. So share it with the print, practice
Yes,
this
sir.
one. So what it says that we have like simple checkbook program. It have 5 actions. It can clear the account balance. It can credit money to an account, debit money to an account, and it can display the current balance, and it can exit the program. For now, you can think that whenever you're crediting money, you are inputting money in that account, and when you're debiting money, you are actually taking money out of that account. For simplicity, you can look up what debit and credit means in case of account if you do not know. And there's another option like clear the account and exit the program. What happens? The whole program runs in a loop. It asks the user to enter a command. First, the command lists are printed so to help the user. It enters a command. Based on that command, it might ask the user to do something else. Like if the user takes the command, chooses the command to credit money into account, it will ask the user for the amount. And then it will credit money into the account. Then it will ask the user for the another command. And this program will keep on looping until the user gives the exit command. In that case, the program will just exit from that place, right at that place, using like maybe break statement or directly return. Also, you can, instead of like writing break statement to break out of a program, like if like I equal to 5, instead of writing like break, we can also write like return 0. If you're in the main function, it will directly exit out of the program. Or if you're using like stdlib.h and maybe we are somewhere else deeper nested, maybe in some other maybe we're in some other function. In that case, we can just by including stdlib, we can write exit and then exit code, like exit 0. I've shown you about exit code beforehand, what are exit codes. So we can just write exit 0. 0 means the execution was completed successfully. So you can also use this method. Okay, so one more thing. If you ever decide to use like goto and you jump to a label, do not put label before declarations. Put them before, put them like in any other place where a normal statement is there. Declaration of variable is not considered as a statement in a normal statement in C. So do not put labels before declarations. Other than that, it is fine. So yeah, practice this one. Okay, so one more thing before coming to the next lab, practice like nested loops. That means loops inside loops. Try to be like more familiar with loops. Try to solve this problem. Also let the other section know about this. I have also told them to like take a screenshot of this problem, practice this one, tell other section about this one as well, and tell them to practice the nested loops, like loops inside loops. Question regarding nested loop will come in your next lab. Okay, so this is the final topic, the now statement. So let us go back into like our prime example. So I'll just like copy one example. So this was our prime example, right? We start from like d is equal to 2, go up to n, check up to n, and then if it is ever broken prematurely, we say that it is the prime, right? So we have the if-else condition here. This was the prime example. So let us try to read this loop verbally. What does the loop say? We start with d is equal to 2. At every step, we increment d by 1. We keep on looping as long as the value of d, or the divisor, is less than the number n itself. And inside the loop body, we say at any moment, if n is divisible by d, at any moment, if n is divisible by d, in that case, break out of the loop. However, we can rephrase this thing like this whole for loop. First of all, verbally, begin or start with d is equal to 2. At every step, increase d by 1 and continue the loop as long as d is less than n and n cannot be divided by d. So we can write and not n% d equal to 0. We do not need this body anymore. What does it say? Start d is equal to 2. At every step, increase by 1. That's fine. Keep looping as long as d is less than n. And this one means n is divisible by d. And by putting a not, we are saying that as long as n is not divisible by d. Start with d is equal to 2. Continue until either d becomes n or n can be divided by d. So that's the condition that we have written in this for loop. Now, do we need to put anything inside the body of this loop?
No, sir.
Right? The loop itself is doing all the work for us.
Yes, sir.
We do not need to do anything inside the loop. So what we can do, we can give the loop an empty compound statement like this one to keep the loop body empty. Or like if I do not put anything, this is not valid, right? Because if there is a for loop or if there is a for keyword and then the expressions there, the next statement that it finds, like printf something, if it finds, it will be regarded as the body of this for, right? That's the rule of C. Whenever parsing the for statement, what C looks at is first the keyword for, then some condition inside a bracket. When the bracket is over, right after that, whatever statement comes next, it doesn't matter. Maybe there are like 5 lines gap and then the statement comes. This statement will become the body of this for loop. So in order to prevent it, we need to give something this for loop. We can give a semicolon. This is by itself, a semicolon by itself, if it does not have any other thing before it, is an empty statement or a null statement. So basically we're saying that the body of this for loop is empty. We can put it anywhere we like. So that's it. Now this becomes the whole for loop. And afterwards we can like do the checks and print whether it is prime or not. So one thing, whenever we're writing the null statement, instead of writing them right after the for loop, since people might miss it or think of it like, okay, so the programmer might have mistakenly put it there because people make a lot of mistake like this. Generally, people put it in a different line, in an empty line by itself. so that it is understandable for the reader that yes, this was deliberately put here. This for loop does all of its work inside the loop itself, and so it is an empty-bodied for loop here. It can be made empty-bodied like this and without a break. And if you ever made an empty-bodied for loop, then put the null statement in a separate line so that the reader can understand. Is it clear? The null statement?
Yes, sir.
Yes, sir.
Okay. So some pitfalls. This is the last topic. Like it will take 2 slides. That occurs. Like here. This is another null statement. However, if you write like if d equal to 0, then printf division by 0 error. But if you put the null statement here, what will happen? The next statement that comes after the if brackets is considered part of the if. However, since we have put a null statement there, now this becomes the body of the if, this null statement, and this printf statement is no more under this if. As a result, if you run this code, whether d is 0 or not, error division by 0 will always be printed because this is not the body of the if, this null statement is. Another example, like inside of for loop. We were supposed to decrement I every time and then print print first t minus that and counting and then decrement I by 1. However, we have mistakenly put a null statement there. As a result, this is no more the body of the while loop. This null statement is the body. So what will happen? At every time, the loop will compare I is greater than 0. Since I was 10, it will be true. Then it will just execute the null statement. Nothing happens. It goes back inside the loop checking. It again executes I is greater than 0 and it gets stuck in an infinite loop. And this will never be executed because it's in this infinite loop here. That's another common mistake. And another one is that like if we put the minus I here, it is fine. But we have again mistakenly put a null statement there. And then we have the printf statement here. What will happen? It's no more part of the while statement here. So I will start from 11. It will keep on decrementing and it will decrement down to 0. And only then the while loop will finish. But at every step, it has actually executed the null statement. So nothing printed. And finally, we have the a detached printf statement, which is not part of this while loop at line number 3. So at the very end, this printf statement will always be executed and it will just print t minus 0 and counting. So you people even in the last lab with the if else one, some of you already had made mistake with the null statement. You have mistakenly put null statement after else if some condition, then semicolon right there, or maybe some have done after the if. So I have seen you people making mistake with the null statement. So anyways, so this null statement can cause problems. So be careful when you are putting them. In most cases, you will not be needing something like this. It's very common in some places, like when defining macros. We will take a look at macros later. That's an advanced topic and it's not necessary. You can also learn it by yourself later on. We'll take a look at macros later. And they're commonly used in cases with string operations, like string comparison or string copying, because it becomes handy and small. But again, that's not required. So if you do not need the null statement, if you then keep the loop body and the conditions separated and keep your code clean. Anyways, so that's all for today. Any question regarding today's class? Or null statement, anything? No question from any of you?
No, sir.
Okay, if there is no question, I think I can stop recording. So I have to take present because all of you are not actually present today. So I'll try to be as quick as I can. So give your present. If some of your mic are not working, then write in the chat. And after I am done, is Tamim here? Tamim Shokar? Yes, Tamim Shokar.
Yes,
after I'm done, I will go through the absent list again and I'll call the name. If you see them in the chat, let me know. Okay, Mohammad Abu Hana Sadid. Arya Rashid Khan Sifat.
Present, sir.
Abu Zaab Mohammad Ridwan Hussain.
Present, sir.
Mohammad Arafat Hussain Anjar. Absent, I think. Tasif Tasor Dipto.
Present, sir.
Asif Abrar.
Present, sir.
Asif Mahmoud Fahim. Asif Mohammed Fahim, Karim Tasim Ridi,
Present, sir.
Fahim Abrar,
Yes, sir.
Chaudhary Blossom Ibn Razak,
Present, sir.
Fardin Fayaz.
sir.
Who
Sir,
said yes, sir?
Fardin Fayaz present. Sir, Fardin Fayaz 11 present.
Yes.
Sir,
Who said yes, sir? Right now?
ID 109 present, sir.
Yeah, I have given present 109. Fardin Fayaz present. Labib Muntasir,
Present, sir.
Ehsanul Haq.
Present, sir.
Give me a moment. Tanbir Chaudhary,
Present, sir.
Arun Bashir,
Present, sir.
Iftikhar Zaman Ifti.
Present, sir.
Okay, also, if you are done with the present, you can leave. Mohammad Naim Mobashir Munim,
Present, sir.
Laiba Nawar,
Present, sir.
Aziz Amin Yasser Alam,
Present, sir.
Awad Ishma Marian,
Present, sir.
Akif Kaisar,
Present, sir.
Adib bin Kabir,
Present, sir.
Yusuf Ibn Kamal Niloy,
Present, sir.
Miftul Alam Siam,
Present, sir.
Mehdi Ahmed,
Present, sir.
Abdullah,
Present, sir.
Mustabshir Ibn Amin,
Present, sir.
Mosasimul Doha,
Present, sir.
Maruf Ahmed,
Present, sir.
Amnun Asfar,
Present, sir.
Ramisa Zaman Audhi,
Present, sir.
Najib bin Tabassum,
Present, sir.
Mohammad Tamim Sarkar,
Present, sir.
Sadia Sultana. Sadia Sultana, she is absent today. Shadman Nahian, Mehrin Tazin,
Present, sir.
Sadiq Salman,
Present, sir.
Muhtasim Kamal Dihan,
Present, sir.
Mohammad Zannatul Samaruk,
Present, sir.
Mushfiqur Rahman,
Present, sir.
Taima Situl Mona,
Present, sir.
Adid Hussain,
Present, sir.
Nain F. Siddiqui,
Present, sir.
Tanvir Hossain Dihan,
Present, sir.
Shamia Sharmin Divana,
Present, sir.
Shoaib bin Hassan,
Present, sir.
Arif Safwan Haq,
Present, sir.
Safwan Saqib,
Present, sir.
Ryan Ilham,
Present, sir.
Amim Ahmed,
Present, sir.
Tanvir Ahmed Tanmoy,
Present, sir.
Sabbir Alam Saad,
Present, sir.
Tanvir Hassan Ananto,
Present, sir.
Munzer Mahmud,
Present, sir.
Amina Rafa,
Present, sir.
Wasalu Tufi 7 year,
Present, sir.
Arsalan Waqif Shah,
Present, sir.
Idris Farash, Berinu Farash, Penda Kolebeli, Abdul Halim Hadroni, Alom Alzin, Ibrahim Ahmed, Ibrahim Muhammad, I'll call the name again of those who are not. Asif Abrar, Sadia Sultana, Idris Farash, Penda, Hadaruni, Alom Alzin, okay, so let me do one calculation. Okay, yeah, the present is correct. Okay, thank you everyone. And also have a great weekend and do attend the quiz. I hope inshallah all of you will be able to do well.
Sir,
Yes, Amina Rafa.
sir, actually, there is an issue with my name. My name is only Amina, not Arafa.
So like, where did this? So your name is only Amina, right?
Yes, sir.
You have like no other part in your name.
Arafa is also my name, but in the papers, it is only Amina.
I'll put Arafa in a bracket here. So in papers, like in national ID and all other places, it's just Amina, right?
Yes, sir.
So like, I might keep on calling you Amina Arafa because having like just one single name might cause conflict in some cases, but it's fine. I'll remember it. Okay.
Yes, sir. Thank you.
Welcome. All of you can leave.
Assalamu alaikum.
Walaikum assalam.
Sir.
Assalamu alaikum, sir.
Walaikum assalam. I'll end the meeting.